Ever wondered how a web application works? How your favorite websites transform your clicks into dynamic, interactive experiences? Well, it's a whole lot more than just flashy graphics and clever code. It's all about the architecture, the grand design that governs how all the elements work together. Web application architecture is a framework that determines how web apps function. It's the backbone that supports the smooth interaction between the user, the browser, and the server. It's the blueprint that enables the creation of those captivating, immersive web experiences we all love. This architecture is composed of three main elements. First, the client-side or front-end components, the part you interact with. Then, the server-side or back-end components, where all the heavy lifting happens. And finally, data storage, the secure vault where all your data is kept. So, let's break these components down and discover how they function. First up, the client-side or front-end components. These are the bits you interact with when you visit a web page. Let's begin with the user interface, or UI. The UI is the stage where the web application performs, and it's composed of HTML, CSS, and JavaScript. HTML forms the structure of the web page, CSS adds the visual flair, and JavaScript makes it interactive. For example, when you click on a button and a menu pops up, that's JavaScript at work. Next, we have client-side frameworks. These are the architects of interactive and dynamic user interfaces. Frameworks like React, Angular, or Vue.js provide a structured way to build the UI. Think of it as a Lego set, where each piece or component is designed to fit together seamlessly, creating a comprehensive whole. Moving on, we encounter responsive design. This ensures the web application adapts to different screen sizes and devices, providing a consistent user experience. Whether you're viewing a website on your laptop, tablet, or smartphone, responsive design ensures it looks good and functions well. It's like a chameleon, effortlessly adapting to its environment. Lastly, we have the browser. This is the medium through which you interact with the web application. The browser is responsible for interpreting and rendering HTML and CSS and executing JavaScript. When you type in a URL, the browser fetches the web page, interprets the code, and presents it to you in a human-friendly format. It's like a translator, seamlessly converting code into a visual experience. So, to sum up, front-end components are all about the user. They're responsible for everything you see and interact with on a web page, from the structure and style of the page to the interactive elements, and even how the page looks on different devices. It's a blend of creativity and technical skill, designed to deliver a smooth and engaging user experience. In essence, the front end is all about delivering a smooth and engaging user experience. Now, while you're interacting with the front end, there's a lot happening behind the scenes in the back end. The back end is like the kitchen of a restaurant. You may not see it, but it's where all the magic happens. And the first magician in our kitchen is the web server. It's the opening act, handling the incoming HTTP requests from clients and returning HTTP responses. Some of the popular web servers you might have heard of include Apache, Nginx, and Microsoft ICE. Next, we have the application server. Think of it as the head chef. It executes the back-end application code and communicates with databases and external services. There are different types of chefs, just like there are different application servers. Some examples include Node.js, Flask, Django, Ruby on Rails, and Java-based servers like Tomcat and Jetty. Now, to help our head chef stay organized and efficient, we have back-end frameworks. These frameworks provide a structured way to cook up server-side applications. Some examples of these handy helpers include ExpressJS's Django, Ruby on Rails, Flask, and Spring Boot. Then we have the database. This is like the pantry or the cold storage where all the ingredients are stored. It stores and retrieves data used by the web application. Databases can be categorized into relational types like MySQL and PostgreSQL, or NoSQL types like MongoDB and Cassandra. Next up is the API, or Application Programming Interface. This is like the serving hatch or window in our kitchen analogy. It defines how the front-end and back-end components communicate, basically how the dishes are passed from the kitchen to the dining area. RESTful APIs, GraphQL, and JSON RPC are some common communication protocols that APIs use. Last but not least, we have the middleware. These are like the kitchen hands, doing important tasks like chopping, peeling, and washing. In the back-end, middleware handles tasks such as authentication, logging, and caching. Some examples include authentication middleware, logging middleware, and caching middleware. Each of these components plays a crucial role in the back-end, working together to process requests and serve responses. Much like how every member of a kitchen staff has a role to play, from the head chef to the kitchen hands, in preparing and serving a meal. So, the back-end is the powerhouse that drives the web application, processing requests and serving responses. All this interaction generates data, but where does it go? That's where data storage comes in. Let's start with databases. These are the bread and butter of data storage. They store and retrieve structured data, serving as the primary source of information for your web application. Databases come in different flavors. Relational databases like MySQL or PostgreSQL use SQL or structured query language to manage data. They're fantastic for structured data and complex queries. On the other hand, we have non-relational databases or NoSQL databases, such as MongoDB or Cassandra. These are designed to handle unstructured data, making them ideal for scalability and handling large volumes of data. Moving on, let's talk about caching systems. These are like the superheroes of data storage, swooping in to save the day when performance needs a boost. Caching systems like Redis or Memcached Store frequently access data in a cache, a high-speed storage layer. Imagine you're running a restaurant. Your most popular dish is always ready to go, so customers don't have to wait. That's what a cache does for your data. It keeps the most frequently used data ready to serve, reducing the load on your databases and ensuring a swift response. Last but not least, we have data warehouses. These are the grand libraries of information, used for analytical processing and business intelligence. Picture a giant warehouse filled with shelves of data. These shelves are organized in a way that makes it easy to analyze and understand patterns, trends, and insights. Data warehouses like Google's BigQuery or Amazon Redshift provide a powerful tool for businesses to make informed decisions based on their data. So, whether it's the structured storage of databases, the speed of caching systems, or the analytical power of data warehouses, each component plays a crucial role in managing and utilizing the data generated by your web application. Data storage systems ensure that your data is safely stored and readily available when needed. So, we've unraveled the components of web application architecture. Let's quickly recap. In the vast labyrinth of web application architecture, we've discovered that the front end is the user's playground. It's where the magic of user interaction happens, with HTML, CSS, and JavaScript making up the visual and interactive elements of a web page. Frameworks like React, Angular, and Vue.js help structure this interactive space, while responsive design ensures a consistent user experience across different screen sizes and devices. Navigating through the backend, we've encountered web servers like Apache, Nginx, and Microsoft DICE, handling incoming HTTP requests and returning responses. It's here that the application server takes the stage, executing backend code and interacting with databases and external services. Backend frameworks, such as Express.js, Django, Ruby on Rails, Flask, and Spring Boot, provide a structured approach to building server-side applications. And let's not forget about the essential role of middleware, handling critical tasks like authentication, logging, and caching. These are the unsung heroes, working behind the scenes to keep the web application running smoothly. The API is the bridge that connects the front end and the back end, defining how they communicate. Whether it's RESTful APIs, GraphQL, or JSON RPC, these communication protocols are the glue that binds the different components together. Finally, our journey led us to explore the world of data storage. We've seen how databases store and retrieve the data that powers web applications, with options ranging from relational databases like MySQL and PostgreSQL to NoSQL databases such as MongoDB and Cassandra. We also learned about caching systems and data warehouses, both playing vital roles in enhancing performance and facilitating analytical processing. And there you have it, a simplified guide to web application architecture. Remember, every click, every interaction on a web page, every piece of data stored and retrieved, it all comes down to these components working seamlessly together.